So how did you first hear about SpaceSim?
Well, on the grade 8 information night, they were serving liquid nitrogen marshmallows and also doing demonstrations with liquid nitrogen and other things. And from the first time I saw that, I wanted to come to SpaceSim.
An alumnus told me about it a couple months before I came to the school.
I first heard about SpaceSim when the principal from Lisgar came to my school to talk about Lisgar and what it had. And one of the things that she highlighted was SpaceSim, and from that moment I was interested because it seemed like a really cool idea and concept. So when I first got to Lisgar, one of the first things that I was looking at was SpaceSim, and I ended up joining it in my grade 9 year.
Well, I knew an alumnus beforehand, and he talked to me about it, and it sounded really cool. And then I came here, and I found people here who were in SpaceSim, and then I kind of followed them to SpaceSim.
I heard about SpaceSim from a friend who was very excited about it, and I didn't know anything about the club, but I went with them, and I was a little skeptical at first, but it turned out to be super awesome.
Welcome to SpaceSim. This is our main location at 440 Albert, where we have our missions and do the bulk of our training, planning, and general simulating. The opening room is MC. This is where the Earth team is based. Other times, it is usually devoted to training and meetings. Next is the Simloft. This is where the simulators are based. The simulators use specialized software to cause disasters for the astronauts. On the left is Keplernicus, our storage room.
Now we enter the habitat. This building is where the astronauts live during the mission. This particular room is the longhouse. It is where the astronauts sleep during the mission. We turn right and enter the interlock. This serves as a kitchen and a general meeting space. The next room is command and control. This is where the astronauts monitor everything. The last room is the airlock.
Now for the last module of the SpaceSim base, the planetary surface. Every year the surface is rebuilt to simulate the surface of this year's chosen planet. This year the surface is the Moon Enceladus. We have included geological features such as ridges called tiger stripes, mineral-filled pockets, ice falls, and geysers. Now that we have explored the surface, we can return to Earth.
So we're taking out one of these samples from the sample container, and we're just going to have a look at it right now. So this is the sample that we took out, and what we usually use the scoopia to kind of move around samples, so we're just going to cut this up. I'm going to hold it down, we're going to cut it up. And now we can kind of see the inside, and we can just kind of see what it's made of. So if we want to try something else, maybe we have this sample that we did find. And this is a different substance, and it's a much drier substance that just breaks apart really easy. So if we wanted to, we could take some of these flakes, cut them up a bit. Now we have a small piece we can put in a small sample container. And with this we could fill it up with water and we could see if it dissolves or anything, because we have its own little bit and we still have the rest of the sample, which we can now put away because we don't need it anymore.
What's the purpose of the hot lab?
The purpose of the hot lab is to really be able to interact with the stuff in the samples that we receive without actually touching them, because the environment that these are stable in is at an incredibly cold temperature sometimes, or incredibly hot depending on where we are. So it's usually safer to be able to use this controlled environment that has the properties of the outside, so we're able to safely use and investigate the materials. Because if we took them out, then they might just melt. Or if we took it out, they might just solidify. So we need to make sure that it's in the same spot as it was when we found it. So we have the best results on what they're made of, what they do, and how they work.
The main event in a year at Space Sim is the mission. However, before the mission can happen, lots of preparation is required. The destination has to be chosen, the surface has to be built, but most of all, everyone has to be trained. Mini missions are a large part of training. These missions are about 1 to 3 hours and focus on a particular aspect of the mission, like taking off, exploring the surface, or dealing with simulated disasters. In this mini mission, the astronauts practice taking off and landing with a few disasters from the simulators.
So you're gonna hit E and W, and he's gonna get hit capital Z. Okay? So 3,
Capital.
3, 2, 1, go. Say we have SRBs are on.
SRBs
are on.
SRBs are on. Engine is enabled. We are taking off. Over.
Oh, stay zoomed in, stay zoomed in.
Say
Stay
next.
zoomed in.
No. You also said center on
Tab.
Center on tab.
Ask repeat. This is actually more.
Please repeat last. Over.
Shift up.
Turn on your radar and engineering with capital R. Over.
Garrett.
Say confirmed.
Confirmed. Zoom in. Next step, please. Over.
Okay, you can zoom in now.
That's wrong button.
Press
At an
minus.
altitude of 15 kilometers, initiate 2-degree counterclockwise roll.
2-degree roll. Okay. 2-degree roll.
Okay.
How do you do that?
Guys, Garrett, do you know how to do a 2-degree roll?
Which direction?
Counterclockwise.
Yeah.
7 or 9. I don't know which one's counterclockwise. One of them.
Okay.
Neither of
Please
those.
stand by until your radiator.
No.
Sorry, SRBs. Over.
Ask them if we are turning in the right direction.
Are we turning in the right direction? Over.
Or are we supposed to turn? I don't know.
Yeah, 2 degrees roll counterclockwise.
You're turning in the right direction, but you need to turn faster. Over.
We have increased the roll.
Alright, I'm getting it that they have their fuel load. Do you guys have their fuel load?
12,000?
Yep. Okay, good. Tell them to turn on their engines.
Okay,
They turn on engine injectors also.
Yeah, power up their engines and turn on their engine injectors.
So 1, 2, and FGHJKLM.
You can now turn on your engines, your engine injectors, and RCSP. Over.
Waiting for engineering to boot up because their nav mode is still up. There it is. Okay.
What?
Please confirm that you want us to launch. Over.
Turn on their engines. Wait, RCSP and injectors aren't. Should I tell them to do that?
RCSP and engine injectors. They need engine injectors.
Please turn on your engine injectors and RCSP thrusters first.
Please repeat last. Over.
RCSP thrusters,
Please
their
turn on your
injectors are on.
RCSP thrusters and both engine injectors.
Your engine injectors are on. Okay, they're good.
Confirm.
There you go.
Alright,
Now they can
tell
launch.
them.
We can't confirm.
Okay. Tell them that when they launch, when they reach an altitude of 15 kilometers, they need to initiate a 2 degrees counterclockwise roll.
Which is manual and then 7 4 times.
Okay, how much am I telling them? Just after launching?
When they reach an altitude of 15 kilometers, go into a 2 degree clockwise rotation, counterclockwise.
And then tell them how to do it.
They know how to do it. They've done it.
Okay.
Just at the wrong time.
Once you launch, when you're at 15 kilometers of altitude, begin a 2 degrees counterclockwise roll.
Okay. 1-5. Over.
Yes.
And confirmed. Over. Do you know how to initiate the roll? Over.
Confirm.
Acknowledged. We'll tell you when we're ready to launch. Over.
We're ready to launch.
We're ready for launch.
Okay.
Alright, tell them to set their engines to 90, and they can be in when they're ready.
And SRBs.
No,
Okay.
So here's what we're going to do. Since the astronauts are in stable orbit, we're going to be going to engineering here. Can you guys see engineering? Okay. So basically what we're going to be doing is we're going to be selecting the second power bus of the habitat. So we're going to be going over here with the arrow keys. And we need to make sure that it's short-circuited because the cards are misaligned in the closet. So I'm going to get Simon, can you increase the malfunctioning, the short circuiting for the second power bus, please?
Plus sign?
That's it.
Plus key? Yeah, okay.
Okay, so the number should be right here.
How many do we want?
Let's set it to 2.
Yeah, set it to 2 just for that little extra finesse.
Okay.
The finesse,
So
yes.
We're gonna wait for the white time to update it, so we're just gonna hold off for now.
The hab reactor.
Stand by, over.
The hab reactor is heating up.
Confirm that hab reactor is heating up.
It's at 103.
Is hab reactor heating up? Confirm over, please.
It's at 103. 110's when it goes kaboom.
Yeah. No, over 110 and you risk it going kaboom.
Well,
Turn off your main engine, set your target to Earth, and we can confirm that your reactor is heating up. That's probably because your engines are on, and it's heating up very slowly. Over.
Engines are not on. Over.
They were on. Over.
It's still heating up. It just went to 104.
Still heating up steadily.
It's not, it's slowly.
No.
Just say,
Slower, but still.
okay, just say acknowledge.
We're still climbing really high.
Everything's
Please
yellow.
turn off your engines, and then your reactor will stop heating up.
Engines are turned off. Over.
Do they mean through engineering? Ask if they...
In the top left of your flight,
Turn
engine does it say 0? Over.
Oh, it should say 0.
Delete.
Confirm.
It shouldn't be a huge problem. Just keep going. We'll correct the procedures to deal with it. Over.
Set clockwise rotation to 1 degrees. Over.
Okay, so you're going to want to press 9. 2 degrees? What was it?
1.
Okay.
So you want to be at
1 degree. That's good. Over.
Okay. Never mind.
Okay, you're going to... Actually, never mind.
Once you get to like 108 or
When
something.
theta pitch is at 120, press F6. Over.
Press F6. Get ready, get ready.
Yeah.
Get ready, get
120. Get ready to press F6.
Okay.
Once this reaches
Say acknowledged.
Acknowledge?
Now.
Say we're done.
Done.
Who cares about over?
You're over.
We're holding steady at 104.
Can confirm. Over.
Okay.
And 100% on all 3 coolant loops. That's not good. Oh, never mind. I'm not holding steady. We're at 105.
That's fine. You should pay more attention to often to the current and voltage of also the power buses sometimes, and like maybe
the voltage
note,
is at 9,891.
maybe we should note like what's normal, what's not normal.
Right now, okay.
So that's normal if you have all the engines, but if you've got something like that when you don't have any engines, it means that there's a short in one of the buses. So you should just know what each bus has usually.
In the end, the astronauts succeeded in their mission. They successfully landed the HAB and dealt with all the simulated disasters. What kind of stuff have you learned from Space Sim?
I have learned a lot of practical skills like how to build things, how to plan things, how to use drywall, but I've also learned a lot about how to talk with people, how to delegate stuff, and how to communicate.
So much. Like, I can't even say how much. 5 minutes ago, someone just took the time to explain to me what a solenoid was and what it does, so that was really cool.
I've learned that even though I'm not really a sciencey person or the kind of person who this club is really targeted towards, I can still be a productive member, and I really like that. It shows me that I don't need to be like super sciencey to be a productive member of a science club.
Well, it's just always good to be able to work with other people, because if you're an astronaut and you're in the habitat, you need to trust and you need to work with the people on the outside in order to get things done. So I think I really learned a lot about teamwork and being able to cooperate with other people.
I've learned a lot about different technologies, and I've learned about computers. I've learned how to use all the programs that we use. I'm not a master of anything yet, but it's a lot of fun learning all sorts of new things here.
All right, so this is a ice bubble that we've made out of plaster that we put on a balloon, and this bubble of ice was formed when an asteroid impacted into the ice wall, melting it to create the bubble. Inside this bubble, we had mineral deposits from the asteroid that gave the astronauts clues to the composition of the asteroid. And this is our geyser. It was created using a piece of piping, and if you look down, you can see that it goes all the way down into the interior of the surface. So on our latest mission, we made snow using shaving cream and baking soda mixed together, which we shot out of this geyser using a reverse vacuum. And this created the geyser effect while the astronauts were here on the surface. So on Enceladus, tiger stripes of ice are formed by geyser activity on the planet's surface. So we created these geysers the same way that we created the rest of the surface, which is that we started with with aluminum girders that provide a base that we then drape with chicken wire covered with tin foil that is also covered with another layer of drywall. Then we add a second layer of drywall to create texturing, and we then paint that using a mixture of white paint and other colors to provide depth. For example, you can see over here an example of other colors that we have on the surface is this silver ice run that we got from an event that melted some of the ice in the corner here, and we created that using silver spray paint and glitter spray paint.
What do you really like about Space Sim?
I really like the atmosphere. I've learned a lot about science in Space Sim, but beyond that, I just really like the people and how it feels. You know, it's very. I feel like I fit in right away when I get here.
It's pretty cool. I mean, it's the only club in Ottawa that really simulates going into space at all, so I think that's pretty cool.
I like that there's something for everyone to do. Even if you're not somebody who's especially good at computers or at science, there's always something artistic you can do. There's always something for everyone.
Everything. Absolutely everything. I love designing the surface. I love how it's really cool to be nerdy and geeky and love science and math, and I love everything about it.
We're like a family. We're all really good friends, and we just even when we're doing like super productive mission related stuff, we're all having a good time.
One thing that I like is just the people, because there's a lot of really great people, and that's the big part. It's the team.